So what we do is we'll be adding sort of maybe I can say one highest point on a curve, and in the next one what we can say is the highest point on a landscape or surface. But before we do that, let's start and create our geometry. So if we create a rectangle, and let's say we create the rectangle on here as our point, it can be an XY plane, of course we add that too. And I'm not sure, like I don't know, we can say like 1000, 2000 maybe. Or maybe more than that. 5,000. It's a bit small now. Okay, so this is our space. So if we turn this into a surface, and then we can divide these surfaces, divide this surface. You may remember this component from very beginning. So we can divide this, like how many numbers we have? 10, 10, like let's say 15 by 15. Okay. And what we'll be doing is we'll be moving these points in Z direction. Say, we can flatten this for now on Z direction. Okay. And the motion is going to be a random motion based on the number of points we have. So we can say list length. I'm making this a bit fast just to step into Galapagos part. But yeah, you can always like rewatch this part or use the example file. So it's basically the number value, how many numbers we want to have, how many values we want to have, and the range, like we draw let's construct domain, let's say between 250 to 250, sorry, negative, like negative 250 to 250, and we can add this to our range. Okay, our range can be here. I need a bit more space here. And in the Z direction, when we add this, you see that we started to have some points that are moving in Z direction. But the trouble with those is, by the way, we can change the C to increase it, or we can make it larger or smaller. Let's have it as this. We want to create a like a surface out of these points, but what we want to do is we want to have these areas or the boundaries on the same level, right? So in order to proceed with that, we'll grab the control polygon, which is the outside control polygon. Okay, and what we are going to do next is to grab the points that are closest to our polygon and then proceed. But one thing that I miss here is we want to, in order to have the control polygon, we have to convert these points into a surface again. So we type surface from points, and when we connect this, you see that it's not going to work because U count failed to collect data. What we need here is, like, we are having the U value is 15, but then we have to use the U value -1 here, if I'm not mistaken, as a, like, let's say a subtract, put this in and connect this over here. So U value needed to be like this, and when we connect this, oops, it's an addition. It's basically needing one more point in U direction to create the surface. It's sort of a mathematical explanation to it, but it's not therefore it's not the subject of this tutorial. You can really Google this and see a lot of information related to that as well. So then what we see here, we are having these points, but these points are like as if they are working as Nernst curve, and if we interpolate this, all the points are going to be the control points of our surface. We can make it up like this. Okay, and then I'll grab a control polygon, and this is the boundary of my surfaces, as you see, and then these are the points of it. And what I need to do is I need to put these points down, right? So I'll be using a component called deform, point deform. So what it's going to be doing is it's taking this geometry as the geometry and the control points, and we are going to take these points and moving them down, right, or up, so that we are going to use our initial rectangle as our as the piece of our surface. To do so, I'll project my points, right? I'll project these points. Let's say project, and it's going to be XY plane, and you see it's already there. And these are the points. So let's create a vector because it's asking for motion. So my point A, point B, and when I connect this, you see what I'm having is, I preview them all off. See, I have the boundary as my boundary. So I can maybe take this aside, and still I see some points, but okay. And these are the points that we take out. And the one thing that I want to do here is to preview this point, so preview this surface with wireframes. So if we use this, we'll see a wireframe. If we increase the density, like let's say 5 now, we are going to see this as it's like shown, and then we can connect this over here. We can pull out a swatch. Right? And we are seeing this as white. And the next thing that I wanted to do is to find a solution, or how we can move the point around this surface, is basically evaluate surface. As you remember, as you're familiar with my tutorials, put this in, and we are going to use a vector or XYZ vector this time, because we cannot put an MD slider here. So 1.0 can connect here, and you see this point. If we reparameterize this, you see we are able to move this point on the surface. So if we connect the Galapagos genome, one genome is connected here, there is going to be here. And for the fitness value, is what we'll be doing is XYZ, deconstruct the point, and the Z coordinate of this point is going to be my fitness value, right? But there is one thing that I'm pretty sure, right? It needs to be like the height needs to be, the highest point is needs to be 100 somewhere. I'm not sure where, but somewhere it needs to be 200. So there are two things we can do here. We can do that, like if we, as we did in the extremes, we can find a way to say, okay, find the highest point of this landscape. Let's start with that one, and then we can start to find the 200. Okay, we are going to maximize, no threshold, solvers. Let's see every solution, and let's start the solver. So as you see, it's quite fast, and it's find the solution relatively easy here, right? And what was the height of this point? Let's check together. I grab a panel here. Oh, I forgot to put a panel. By the way, when you run Galapagos, you won't be able to run the you won't be able to put any component inside of the browser. So got a panel here, and then it says 200 and like 288. Why we are seeing this value? Because it's basically creating a point somewhere over there. If I create this point, where is that point? Oh, we are not. Yeah, we interpolated, but once we deform this surface, we lose it, right? So if I preview this one, you'll be seeing sort of a point around or pretty close to that portion, as you see here. You see, but when we deform this surface, we have this surface here. So it's basically related to that. Then what I can do here is, again, like double click to it and starting a solver again. You see, it's basically showing us this point as well. So when I preview this, click on that point, our solution needed to be showing that, but we're seeing a lot of. Okay, let me clean this for a second for you to see everything. Where is my point now? Okay, so if I maximize this again, you see it finds the solution. If I reinstate this, like let's reinstate this one, you see it's find that solution, reinstate that one, it goes in there. Because you know why it's basically finding it's quite fast? Because our starting point with the sliders are quite correct. So if I make it really there, it will take longer. And if I now start my solver, you see that point moves quite fast towards that location, but it finds somewhere, like when we reinstate that, it finds a really low value, or even like zero, right? Zero value. So we can reinstate this value and then say okay to this, and it finds the highest point. Okay, so this being said, we can group this all and we can basically finish out this tutorial, this video. In the next one, I'll be talking about how we can minimize something. Okay, I'll see you in the next one.